The pixel that I have chosen to analyze in relation to the water problem on the Campine Plateau is pixel C3. I grew up within this pixel, so it was a logical choice as I already knew the region and could use this knowledge to analyze the surface. The area is located on the edge of and on one of the lowest points of the Campine Plateau and is part of the Bosland region. Bosland is a large wooded area and includes the public nature reserves of 4 villages and are also protected and maintained by these villages. My pixel consists of 3 village centers, Hechtel and Exel, which have merged into one village since 1977, and Weegmaal, a sub-municipality of Peer. In the middle of the pixel is the north-south, the large track that can take us to Eindhoven in the north and to Hasselt in the south. The Ferraris map shows that the road on the left side of the north-south has been there for a long time. A river is also visible here. This is the Dommel that still looks about the same today, only slightly less wide. The spotted parts also show that there was a lot of heather present at that time. The pixel contains an intersection of 3 water basins, namely the Nete, the Maas and the Demer basin. 2 major waterways are also visible. The Grote Nete rises in Hechtel and continues to the Schelde. The Dommel starts just below the pixel in Peer and flows further towards Maastricht. As mentioned earlier, the pixel is located on the edge of and on one of the lowest points of the Campine Plateau. There are also few height differences in the landscape, making it a fairly flat area. The heights fluctuate between 55 and 65 meters above sea level. The soil consists mainly of sand and loamy sand. This is very light soil that retains little nutrients and water. A sandy soil with little nutrients is very loose, so that the water runs directly to the subsoil. A strip of peat is visible at the location of the waterways. The land is mainly used for agriculture and forests. The dark green color represents the coniferous trees that are present in abundance. In the yellow color are the agricultural areas, some of which are no longer actively used. And in the beige color, the urbanized areas can be seen. Then we come to the water problem in my pixel. The biggest water problem in the pixel is the dryness of the subsoil. This map indicates the sensitivity to drought. This is partly due to the urbanization that is hardening the surface, but the orange areas that are most sensitive are the wooded areas. This is mainly because they are coniferous forests. The needles that fall from the trees form a kind of blanket on the ground, which means that much less water can go into the subsoil. It rather remains on the blanket of needles and then evaporates to a large extent, so that the groundwater table is replenished less. Then I would like to talk about my fascination. Fashion has inspired me from an early age, and it's mainly the designs of Iris van Herpen that capture my imagination. She makes luxurious designs, but always gives it its own sustainable, innovative touch. She also uses renewable materials such as mycelium and often 3D prints her dresses. Which brings me straight to the problems that arise in the fashion world. Textile production is responsible for 4% of global groundwater extraction. The treatment and dyeing of textiles is responsible for 20% of industrial water pollution, which is a very large share. That's why I started thinking about a solution. On the one hand, to solve the drought problem in my pixel, but at the same time to tackle the water problems in fashion. That is how I came up with the idea of developing textiles in a sustainable way, in which water plays a major role and could supplement the groundwater table in the pixel. Since my pixel is part of Bosland, it also seemed logical to get started in this area. On the edge of Bosland is a part of Exel, the Vlasmeer, named after the former flax that was grown here. There's also a military base that can be converted into a textile processing company. To develop a textile label, I chose two crops that together can form a new type of textile. The first is flax, from which linen is made. Flax can be grown completely sustainably. It doesn't need extra water and does not pollute. The long fibers of the flax make up 75% of the textile. The long fibers of nettles are used for the other 25% of the textile. These have a similar growth process as flax, but require a different nutrient medium. Flax needs very little nutrition, making it ideal for the current landscape. Nettles need a more nutrient-rich soil. Solving this brings me to my project system. By supplying sewage from the village, the purification and flow fields will make the subsoil richer in nutrients, and nettles can grow around these flow fields. The purified water can then end up in wadis, where it can infiltrate evenly with an overflow in existing sewage system. These wadis will be integrated into the design of the processing company on the former military base. At the building level, there are still a number of interventions that can improve the water problem, such as the reuse of rainwater and the dyeing of textiles in a natural way. Then here's a first overview of the company's warehouses and a global layout of them, in which the company's functions follow logically. And then the layout of the landscape, where also has been looked at how the landscape can be experienced by visitors and what I would like to pass on to these visitors. Which brings me to the last image. A few buildings and functions are already visible here, such as a store where the finished clothing can be sold, and also the wadis that are located between the buildings but still have room for good circulation. More information and details about the system and company can be found on the panels.